welcome to lecture number 19 of fuzzy sets, logic and systems and applications. And here in this lecture, we will have examples on distance between two fuzzy sets, and this lecture is in continuation to lecture number 18, where we have already discussed the formulation for finding the membership values corresponding to the generic variable value, that was lambda, for the distance between two fuzzy sets. So, here before I move to the example, I would quickly go through the formulation. So, here as I mentioned earlier also that when we find the distance between two fuzzy sets, let us say A and B. So, this distance is the fuzzy set, this distance value is fuzzy, and this is represented by a fuzzy set. So, this fuzzy set of course, will have the generic variable value delta as well as its membership values. So, and of course, here the delta is the difference between corresponding generic variable values of two fuzzy sets for a generic variable. So, as it is written here that the distance between two fuzzy sets A and B, that is represented by d of A comma B, which is equal to the summation of all the elements containing its membership values over the universe of discourse. So, summation is used here for the discrete fuzzy set case, and on the same lines we have another formulation where we used integration sign, integration symbol in place of summation, which is here for the continuous case. And the membership value can be calculated by this formulation, and these membership values are nothing but for respective delta values. So, since we have already explained enough in my previous lecture, so let us now directly go to the example. In this example, we have three discrete sets A, B and C, and as I mentioned, these are all discrete fuzzy sets. So, since these are the discrete fuzzy sets, we will apply the summation sign, and we can accordingly manage to get all the values of the table that I already mentioned in the last lecture. So, we have here the fuzzy set A, this fuzzy set which is given here is represented by a fuzzy set plot. So, we have here a fuzzy set A, and then we have fuzzy set B, which is represented by the fuzzy set as shown here, and then we have the third fuzzy set which is here. So, please note that these the generic variable for these fuzzy sets are nothing but the same, the x. So, generic variable is x here in all the cases. So, here let us now start with finding the distance between two discrete fuzzy sets. Here also we have x, here also we have x as generic variable in both the cases, And if we see here, as I mentioned in the last lecture, that we have a table, and this table will have the delta value which is here, and then we have x a. So, x a is nothing but the generic variable value which is present in the discrete set A. Similarly, here is the generic variable value present in fuzzy set B, and here mu A x A and mu B x B both are the respective membership values, and then we take min of these two mu A x A and mu B x B. So, that is how we fill these entries. So, let us now quickly go through, and please note here that we have delta which is here, this is always positive real number. So, that has to be noted because we are using here the mod of x a minus x b. So, obviously, delta is going to be the real positive value. So, let us quickly go through completing this exercise of calculating the difference between the generic variable value, or in other words all the possible differences right from 0 and above. So, when we find all combinations, we get these values of delta. So, this delta will have 1 0 1 2 1 0 3 2 1 4 3 2. So, like that when we rearrange this, we will get delta a set which is 0 1 2 3 4. So, let us now start with delta is equal to 0, and here we will see that we have these two entries, these two pairs for which we get delta is equal to 0. So, it is like this, and these values are filled over here. See here, these values will go here and here. So, x a x b, and of course, this is for delta is equal to 0. Similarly, we will find from the discrete fuzzy set given their respective membership values, and then when we take min, we are going to get 0.4. Now, let us enter the values for the second pair. So, second pair is 3 3, and we can see that these values are entered, and the minimum we are getting here is 0.3. Now, we have to take max of these two. So, this is here is used to compute the max. Max is going to be 0.4, max of these two. So, as I already explained in my last lecture, lecture number 18 and 17 both, that we first arrange all the values of lambda, and then we find all the entries, fill in the table, and then we take the max values in the last column, and then we use first column and the last column for constructing the fuzzy set, and this fuzzy set is nothing but the distance between these two discrete fuzzy sets here. So, now let us move ahead and take delta is equal to 1. So, when we take delta is equal to 1, so we see that these are the combinations, these are the pairs, these 4 pairs are there, and these 4 pairs will be entered in the table. You can see here I am quickly moving ahead, and since you already know as to how we fill these entries, so we can quickly fill these entries here. Now, for delta is equal to 1. So, we get the mean values as listed here, and when we take the max of these, we are going to get 0.9. So, this is written over here. Similarly, let us go and have all these entries for delta is equal to 2. So, when we take delta is equal to 2, we get these 3 pairs, and as I have already explained, these pairs are coming from both the fuzzy sets that are given, both the discrete fuzzy sets A and B. Now, let us fill these entries also here in the table. So, when we fill these entries, we are going to get here all the entries filled, and we see here that we are getting the max of all these as 1. So, this way we are getting mu d a comma b of delta 1. So, now let us move ahead and find all the entries for delta is equal to 3. So, when we move ahead, we see that we have 2 pairs which are resulting delta is equal to 3. So, let us fill these entries as well. So, when we fill these entries, we find that the min is coming as 0.2, and then for the second pair, when we see, we are getting 0.4 as the min of these two. And as we have done in previous entries, we take the max here finally, and when we take max, we are going to get 0.4. So, that is how we have entered here 0.4. Now, for the last value, that is delta is equal to 4. So, when we take delta is equal to 4, we are getting here 5 and 1, only one pair, for which we are getting the difference, that is delta 4, and this we are entering here. And of course, since we have only one row here, so max is going to be the same, that is 0.2. So, when we do that, we quickly get all the delta values which are mentioned in the first column and the corresponding membership values that are mentioned in the last column. So, now we make use of these two columns, like for delta is equal to 0, the corresponding membership value is 0.4, and then for delta is equal to 1, corresponding membership value is 0.9, and then for delta is equal to 2, corresponding membership value is 1 here, and then for delta is equal to 3, the corresponding membership value is 4. Similarly, for delta is equal to 4, we are getting corresponding membership value 0.2. Now, let us make use of this to construct the fuzzy set, which is the resultant fuzzy set, which is nothing but the distance. So, here we have the distance between two fuzzy sets A and B. So, since we have written here, we have made the use of the entries of column number 1 and the first column and last column, and then we are getting here all these entries. And when we construct a fuzzy set, this will look like this. This is nothing but the distance between two fuzzy sets A and B. And this way we are able to get the distance between two fuzzy sets. Here in this case, we have two discrete fuzzy sets, and that is how we are able to calculate the distance, and which is again coming out to be a discrete fuzzy set. Now, We have a MATLAB code here. So, if you are interested, you can make use of these MATLAB codes. You can generate, you can compute the distance between two fuzzy sets A and B, and then you can generate the resultant fuzzy set. So, this is the same code that was used to generate all these figures, plots and entries as well. So, let us now take another example here, where we have to compute the distance between two discrete fuzzy sets A and C. In earlier case, we computed the distance between fuzzy set A and fuzzy set C. Here, we are computing the distance between fuzzy set A and fuzzy set C. So, since these sets are already given, A has been given like this and C fuzzy set has been given like this. Both of these fuzzy sets are discrete fuzzy sets. Again I am writing this discrete fuzzy sets. So, of course, as we have seen in the previous examples, that the resultant fuzzy set, the distance is also going to be the discrete fuzzy set. So, here also we see that we have the generic variable x in both the cases, and when we take these two fuzzy sets again on the same lines as we have done in the previous example, if we try to find the delta values. So, as I had already explained, and I already suggested that we should start with delta is equal to 0. So, for delta is equal to 0 here, we get these pairs from x a and x c, the generic variables of both the fuzzy sets, and in this case delta is equal to 0, we are getting only one pair, that is 5, 5. So, let us quickly enter this value in the table. So, as we have already seen in the previous examples, we have a delta column, which is the first column. So, let us enter the delta value, and this is nothing but 0. So, we enter here in the first row, we are entering here delta is equal to 0. Now, let us quickly take these values of x a and x c, which are like this 5 and 5, for which delta is coming out to be 0. So, we can fill these entries, and now we will go ahead and find the corresponding membership values. So, let us now see what are the corresponding membership values. So, here if we see 5 is from here. So, corresponding membership value here is 1, and then in the fuzzy set C, we see that we have corresponding to 5, we have membership value here as 0.3. So, when we take minimum of these two, we are getting 0.3, and then similarly, see here we have delta is equal to 0, we have only one row. So, the max of 0.3, since we have only one element, so we can straight away write 0.3. So, this way we are able to enter the first row values for delta is equal to 0. Now, let us quickly go ahead and take delta is equal to 1. So, we have delta is equal to 1 here, and let us find all these pairs which are responsible for creating delta is equal to 1. So, we have two pairs here, first pair and the second pair. First pair is 4 5, second pair is 5 6. So, let us now enter these values. So, first pair here is for delta is equal to 1, we have x a 4 and x c 5, and here we have 5, the other pair values 6 like this, and then we will find the corresponding membership values. So, corresponding membership value here will be 0.9 corresponding to 4. So, 0.9, and then corresponding to 5 we have 0.3. Similarly, For 5, 6 we have here corresponding to 5 we have membership value 1, and then we have here corresponding to 6 we have 0.8. So, now here if we take minimum of these two we are getting 0.3 and minimum of these two we are getting 0.8. When we take maximum of these two we are getting 0.8. So, this is how we are able to enter the values corresponding to delta is equal to 1. Now, let us enter the values of delta is equal to 2. So, when we take delta is equal to 2, so let us see how many pairs we get which are giving us the delta is equal to 2, the difference 2. So, we get 3 pairs. So, first pair, second pair and third pair, all these pairs are responsible for generating the difference of 2. So, let us now quickly enter these values here, and we know as to how we enter these values, and then when we take maximum of these we are going to get 1. So, this is how we are getting the corresponding to delta is equal to 2, we are getting its corresponding membership value as 1. So, now let us find the number of pairs for delta is equal to 3. So, here we see that there are 4 pairs which are coming from fuzzy set A and C as x a and x e values and the generic variable values. So, these 4 pairs let us enter quickly here in the table. So, here we have entered all these values, and then when we take maximum we are getting here as 0.9. Similarly, now let us go ahead and find all those pairs which are responsible for generating the difference, that is delta, this is equal to 4. So, delta is equal to 4. Let us see how many pairs are responsible for generating. So, there are 3 pairs. So, first pair here 2 6 and then 3 7 and 4 8. These 3 pairs are responsible for generating delta is equal to 4. So, delta is equal to 4, as I already mentioned, is nothing but the difference between the x a and x e, and these values are basically the generic variable values, and these values are coming from the fuzzy sets that are given to us. Here in this case these fuzzy sets are A and C, and these both the fuzzy sets are discrete fuzzy sets. So, this way we are able to quickly manage to enter all the values in the table corresponding to delta is equal to 4, and the maximum value that we are getting here is the max of all these entries we are getting here as 0.7. Now, let us do the same exercise for delta is equal to 5, and when we see we are getting 2 pairs 2 7 and 3 8, and both are responsible for delta is equal to 5. So, let us enter these values here, and here we are getting 0.7 as the maximum of 0.7 and 0.3. So, this way this is also done, and now let us go ahead and try to find all the entries corresponding to delta is equal to 6. So, when we want to have the difference of 6, let us see how many pairs that we are having which are responsible for creating the difference of 6. So, this is pair of 2 and 8 which is responsible for creating delta is equal to 6, that is the difference. And of course, as I already mentioned that this is coming from the A set and this is coming from the 8 is coming from C fuzzy set. So, or in the other words we can say this is the generic variable value from A set and this is the generic variable value from C set. So, here we have only one pair and this pair is responsible for creating the distance of 6. Now, let us enter this quickly. So, we will write here 6 and then we will write here 2, we will write here 8 and then let us now look for the corresponding membership values. We will directly get these values from the fuzzy set that has been given to us. So, corresponding to 2 we are getting its membership value 0.7, this is coming from here from fuzzy set A and now corresponding to 8 which is here. Now, let us quickly find and enter its membership value which is nothing but 0.5. When we take min of these we are getting 0.5 and since we have only one row. So, when it comes to taking max, so max will remain the same. So, this way we got all the entries that are needed to compute the distance between two fuzzy sets. And now, if we see here at the table, we have the first row as the delta row, that is all the possible values of delta are there. And I would like to mention one thing here that see delta is equal to 6 we have computed, we have found all the values, we have entries in the table. So, can we have any entry for delta is equal to 7 also? So, the answer is no, because we cannot find any pair here which are responsible for creating the difference of, that is delta is equal to 7. So, no pair is responsible for creating delta is equal to 7. So, that is how or that is why we are not including the delta is equal to 7, because no pair here is present which can create the difference delta is equal to 7. So, that is why we stop here and in the table we are having only entries of delta up to 6. So, now we are using these delta values and its corresponding membership values which are in the last column, and we see that we have corresponding to delta here which is 0. So, for 0 we are getting 0.3 as the membership value. So, we have written over here and then we have 1 for delta value 1 we have 0.8. So, this is also written, and similarly for all the values of delta up to 6 we have written all the elements, all the membership values, and this d of A and C, this d of A and C means the distance between two fuzzy sets A and C. We are getting a fuzzy set which is nothing but the distance between two discrete fuzzy sets A and B. So, this way we are able to find the distance in between two fuzzy sets, and it is needless to say that here both the fuzzy sets are discrete, and hence we are getting the distance also a discrete fuzzy set, and this can be plotted here like this. So, in the last lecture mentioned as to how we can plot the resultant fuzzy set, which is here you can see. So, here also for the distance between two fuzzy sets A and B, we have the MATLAB code, and you can use this MATLAB code for computing the distance between two fuzzy sets, and this MATLAB code can also be used for plotting the resultant fuzzy sets. Now, let us find the distance between fuzzy sets B and C, where we have B as this discrete fuzzy set which is given, and C here is another fuzzy set which is given by this expression. So, we have again all these two fuzzy sets B and C both are on the same generic variables. So, let us quickly now go ahead and find out the distance between these two fuzzy sets. So, we remember that we first need to find a set of delta values, and these delta values will start from 0. So, we will quickly see that first we will try to find the difference of 0, and for this difference of 0 we try to use the generic variable values of both the sets. So, we see that we do not find any pair, any such pair which creates delta is equal to 0. Similarly, we do not find any such pair which create the difference of 1, that is delta is equal to 1. So, here delta is equal to 0 and 1 we are not including in the set, and then when we move ahead we find that for delta is equal to 2 means the difference of 2 can easily be created, and from the entries that are given in the fuzzy sets B and C. So, 2, 3, 4, 5, 6, 7 all these delta values are possible. We will see as to how we are getting these differences. So, let us take first the delta is equal to 2. So, delta is equal to 2, we have one pair, these entries we have. So, 3 and 5. So, this is one pair, and this pair is responsible for creating the difference of 2, that is delta is equal to 2. So, let us quickly enter all these entries in the table, and that is how we get the max here also 0.3 in the last column. And now, let us quickly go ahead and find all these entries for delta is equal to 3. So, for delta is equal to 3 we see all these entries, and you can follow the same procedure for finding all these entries, and you know, when you take max of these min values here, then you get 0.8 for delta is equal to 3, and let us now see what we are getting for delta is equal to 4. So, for delta is equal to 4 we are getting 3 pairs here, first pair, second pair, and then we have third pair. So, this way we get 3 pairs, and all these 3 pairs we are entering in 3 rows, and then when we take the max of these main entries. So, we are getting 1.0 means 1. So, we quickly get the corresponding to 4 means delta is equal to 4, we are getting its membership value 1. Now, let us take delta is equal to 5, and again we have 3 pairs of x b and x c. So, let us now enter these values on the same manners you see here. So, we get for delta is equal to 5 we get its membership value as 0.5, and when we take delta is equal to 6 we get all these entries filled, and since we have 2 pairs only which are responsible for creating the difference of 6, that is delta is equal to 6, we have 2 rows here, and when we take max of this we are getting 0.4. So, we are having its membership value 0.4. Next is delta is equal to 7. So, for delta is equal to 7 we are having only one pair, and this pair here for delta is equal to 7. So, we enter the values of x b and x c, which are responsible for creating the difference between these as 7. So, we just enter these values here. So, x b here is 1 and x c here is 8, and this way we are getting its corresponding membership values from the fuzzy sets B and C, and that is how we fill these entries. So, we see here that when we pick these membership values and the corresponding delta values from the last column and first column respectively, we see that we are able to get a discrete fuzzy set, and this is nothing but the distance between two fuzzy sets B and C over the generic variable x. So, when we are interested in plotting this, we are getting this plot. So, this plot represents the distance between B and C, and here we have the MATLAB code for finding the distance between two fuzzy sets B and C. So, if you are interested, these MATLAB codes you can use for finding the distance between two fuzzy sets and generating the plot for the resultant discrete fuzzy set. So, this way we have seen that the distance between two fuzzy sets can be found. So, if the fuzzy sets are discrete fuzzy sets, the resultant distance between these two fuzzy sets will be a discrete fuzzy set, and if these fuzzy sets are continuous fuzzy sets, of course, the distance between these two fuzzy sets are going to be the continuous fuzzy sets. So, this way we understood as to how we can manage to find the distance between two fuzzy sets. So, here we will stop and then in the next lecture we will study the fuzzy arithmetic. Thank you very much.